video about examining your data, that is the multivariates technique. We call it's a part of the multivariates data analysis. Let's first talk about the step 3. Previous video we already discussed their above steps. We'll discuss 3 steps, that is diagnosing the randomizedness of the missing data process. The next step is an empirical examination of the pattern of missing data to determine whether the missing data are distributed randomly across the cases and the variables. Hopefully, the missing data will be judged missing completely at random, those allowing the wider range of the remedies in the imputation process. We will first employ a test of comparison between groups of missing or non-missing cases and then conduct an overall test for randomness. The first test for assessing the randomness is to compare two observations with and without missing data for each variable on the other variables. For example, the observation with missing data V2 are placed in one group and those observations with valid responses for V2 are placed in another group. Then these two groups are compared to identify any differences on the remaining matrix variable. V3 through V9, once comparison have been made on all of the variable, new groups are. These are the summary of statistical for reduced sample 6 cases and variable 1 deleted. There is the V3, V4, 5, 6 and V14. These are the number of cases. This is the mean, standard deviation, number and percentage. Summary of cases. Number of missing data per cases, number of cases and percentage of sample. Form base of the missing data for the next variable V3 and the comparison are performed again on the remaining variables. This process continued till each variable V2 through V9 remain. V1 has been excluded, has been examined for any differences. The objective is to identify any systematic missing data process that would be reflected in pattern of significant differences. Table 7 contain the result for this analysis of the 64 remaining observations. The only noticeable pattern of significant t-values occur for V2, for which 3 or 8 comparison V4, V5 and V6 found significant differences between the two groups. Moreover, only one of instance group formed on V4 and compared on V2 shows a significant differences. This analysis that through significant differences can be found due to the missing data on the one variable, the effects are limited to only this variable, making it of marginal concern if later tests of indicate non-random pattern of missing data. These results would provide starting point for possible remedies. The final test is an overall test of the missing data for being missing completely at random. The test makes a comparison of the structural actual pattern of the missing data with what would be expected if the missing data were totally randomly distributed. The missing completely at random data process is indicated by the non-significant statistical level. For example, greater than 0.5 showing that the observed pattern does not differ from the random pattern. This test is performed in a missing value analysis module of the SPSS as well as several other softwares packages dealing with the missing value analysis. In this instance, little missing completely at random test has a significant level of 0.583 indicating a non-significant differences between the observed missing data pattern in the reduced sample and a random pattern. This result completely with the earlier analysis showing minimum differences in a random. This is the table 7, which is shown in the assessing the randomness of the missing data through the group comparison of the observation with the missing values versus valid data. Group formed by the missing data V2, V3 to V9. V2 t value significance, number of cases, missing data, number of cases valid data, means cases missing data. These are the table which shows the result. Note, each cell contains 6 values. T value for the comparison of the means of the column variable across the group form between the group a case with the valid data on the row variable, and group B observation with the missing data on the row variables. Significant of the t value for group comparison and number of cases for group valid data and the group missing data. 5 and 6 mean of the column variable of group valid data on now variable and group missing data on the variable. Interpretation of the table. The upper right cell indicate that the t value for the comparison of the v9 between group of valid data on v2 in the group B missing data of on v2 is 1.2, which has a significant level of 0.233, the sample size of group and the 50 and to 10 respectively. Finally, the mean of the group of valid data V2 is 4.8, whereas the mean of group B missing data in V2 is 5.0. Pattern allow for the missing data process to be considered missing completely at random. As a result, the researcher may employ any of remedies for missing data because no potential wise exists in the pattern of missing data. In step 4, selecting an imputation method, as discussed earlier, numerous imputation method and available for both missing at random and missing completely at random data process. In this instance, the missing completely and at random that process allowed for use of any imputation method. The other factor to consider is the extent of missing data. As the missing data level increase, methods such as the complete information method become less desirable due to the restrictions on the sample size, and the all available method regression and the model based method become non preferred. The first opinion is to use only observation which complete data. The advantage of this approach is in maintaining the consistency in the correlation matrix is offset in the case of, however, its reduction of the sample, so such a sample size 32 cases that is not useful in further analysis. The next option are to still use only valid data through the all available method of the calculate replacement values. Through such method as the mean substitution, the regression based method, even the model will be employed and the compare to assess the differences that arise between methods. They could also form the bias of multiple imputation strategy, whereas all the result of combined into the single overall result. Table 8 detail to result of the estimating mean and the standard deviation for imputation method, mean substitution of all available regression and EM. In comparison, the mean we find a general consistency between the method with no noticeable pattern. For the standard deviation, however, we can see the variance reduction associated with the mean substitutions method across all variable. It consistently provides the small set standard deviation attributable to the substitutional on the content value. The other three method again shows the consistency of the result indicative of the lack of the bias any of method since the missing data process we deem missing completely at random. Finally, table 9 contains the core actions obtained from the complete cases, all available mean substitutions, and EM imputation approach. In most instances, the correlation are similar, but several substantial differences arise. First is a consistency between the correlation obtained with the all available mean substitution EM approaches. Consistent difference occur, however, between these values and these values from the complete cases approach. Second, the notable differences are concentrated in the correlation with V2 and V3, the two variables with the greatest amount of missing data in the reduced sample. Refer back of table 6. These difference may. This is the table 8 that is showing the comparison estimation of mean standard deviation across the four imputation method: estimation method, mean substitution, all available, regression, and EM. The imputation method, this is also the four method. This is the missing data comparison. The correlation obtained the complete all available. This is the mean substitution EM method of imputation. V2 V3. The top value of the correlation obtained with the complete and the method second value obtained with the L available method. The third value is the correlation from the mean substitution method, and the fourth correlation from the EM method of imputation. Indicate the impact of missing data process. Even though the overall randomness test shows no significant pattern, although the researcher has no proof of greater validity for any of the approaches, these results demonstrate the marked differences sometimes obtained between the approaches. Whichever approach is chosen, the researcher should examine the correlation obtained by alternative method to understand the range of possible value. The task for the researcher is to coalesce the missing data pattern with the strength and the weakness of each approaches and then select the most appropriate method. In the instances of offering the estimate, the more conservative approach of combining the estimation into the single estimate, the multiple imputation approaches may be the most appropriate choice. Whichever approach is used, the data set with replacement values should be several for the further analysis. A recap of the missing values analysis. Evaluation of the issue surrounding missing data in the data set can be summarized in four conclusions. Number one, the missing data process is missing completely at random. All the diagnostic techniques support the conclusion that no systematic missing data process exists. Making the missing data MCAR, we call it missing completely at random. Such as finding provide two advantages the researcher. First, it should not involve any hidden impact on the result. The need to be considered when interpreting the results. Second, any of imputation method can be applied as remedies for the missing data. Their selection need not be based on their ability to handle the non-random purchases, but instead of this application of this process and its impact on the result. Imputation is the most logical courses of action. Even given the benefit of deleting an variable, the researcher is precluded from the simple solution of using the complete case method because it results an inadequate sample size. Some form of imputation therefore needed to maintain an inadequate sample size for any multivariate analysis. Impute correlation difference across technique. When the estimation correlation among the variable in the presence of missing data, the researcher can choose from commonly employed technique, the complete case method, all available information method, the mean substitution method, and EM method. The researcher is faced in the situation, however, with different cases in the result among the method. The all available information, mean substitution, and EM approaches lead to generally consistent result. Notably, differences, however, are formed between these approaches and the complete information approaches. Even though the complete information approaches would seem the most safe and the conservative, in these cases is not random due to the small sample used, only 26 observation, and it marked differences from the other two methods. The researcher should uh, case choose among the other approaches. Multiple method for replacing the data and available and approaches. As the already mentioned, mean substitution is one acceptable mean on generating replacement values for the missing data. The research also has available the regression and EM imputation method, each of which given reasonable consistent estimation for most variable. The presence of several acceptance methods also enable the researcher to combine the estimation into the single composite, hopefully mitigating an effect strictly due to one of the method. In conclusion, the analytical tool and the diagnostic process presented in the earlier session provide an adequate bias, understanding and accommodating the missing data found in the pretest data. As this example demonstrates that the researcher need not fear that missing data will always produce a multivariate analysis or always limit the generalizability of the result. Instead, the possible hidden impact of the missing data can be identified and action taken to minimize the effect of missing data the analysis performed. Let's talk about the outliers. What is the outlier? Outlier are observations with the unique combination of the characteristics identifiable as a distinctly different from the other observation. What what constitute of unique characteristic? Typically, it is judged to be unusual higher of low value on a variable of unique combination of the value across the several variables that make the observation stand out from the other. In assessing the impact of outlier, we must consider the practical and the substantive consideration. From the practical standpoint, outlier can have a marked effect on any type of empirical analysis. For example, assume that we sample 20 individuals to determine the average household income. In our sample, we gather the responses that range between the $20,000 and the 1 lakh, so that the average is 45,000. But assume that the 21st person has an income of the $1 million. If we include the value in the analysis, the average income increased to more than 90,000. Obviously, the outlier is a valid case, but what is the better estimation the average household income, 45,000 or 90,000? The researcher must assess whether the outlying value is the retain of the eliminated due to the underlying influence of the result. In subsi- in, in substantive term, the outlier must be viewed in light of the how representative it is the population. Again, using our example of household income, how representative of the more wealthy assigned in the millionaire. If the researcher feel that it is a small but uh, viable segment in the population, then the perhaps the value should be retained. If however this millionaire is the only one of the entire population and truly far above everyone else that is unique and represent an extreme value, then it may be deleted. Outlier cannot be categorical characterized as either beneficial or problematic, but instead of must be viewed within the context of the analysis and should be evaluated by the type of information. They may provide when beneficial outlier, although differences from the majority of the sample may be indicative of the characteristic of the population that would not be discovered in the normal course of analysis in context. But problematic outlier are not be representative on the population are counted to be objective of the analysis and can seriously disorder statistical. Honoring the very varying the impact of outlier, it is the imperative that the researcher examine the data for the presence of the outlier and ascertain their type of influence. Additionally, outlier should be the place of the framework, particularly suited the assessing the influence of individual observation and determining whether the influence is helpful or harmful. Why do outlier occur? Outlier can be classified into one or four classes based on the source of their uniqueness. The first class arises from the procedural errors such as the data error or mistake in coding. These outlier could be identified in the cleaning stage, but it overlooked. They should be eliminated or recorded of missing. The second class of the outlier is the observation that occur as the result of the extraordinary event with account for the unique of the observation. For example, assume we are tracking average daily rainfall when we have a hurricane that at least several days and the record extremely high rainfall else these rainfall levels are not comparable to analyze else recorded in the normal weather pattern. If included, they will markedly change the pattern of the result. The researcher must decide whether the extraordinary event fit the objective of the result. If so, outliers should be retained in the analysis. If not, if should be deleted. The third case of outlier comparison, extraordinary observation, for which the researcher has no explanation. In this instance, a unique and the markedly different profile emerge. Although these outliers are the most likely to be omitted, they may be retained if the researcher feel they represent valid element of the population. Perhaps they represent the emerging element of an untapped element previously not identified. Here the researcher must use judgment in the retention, deletion and decision. The fourth and the final class outlier contain observations that fall within the ordinary range of the value of the each of the variable. These observations are not particularly high or low of the variable, but unique in their combination of the value across the variables. In this situation, the researcher should retain the observation unique. The specified evidence is available that disconnect the outlier as a value of number of the population. These are the first class arise the procedural error, and the second is the outlier is the observation occur the result of extraordinary event. The third is the outlier comparison, extraordinary observation for which the researcher has no explanation. And the fourth is the final class of outlier contain the observation that fall within the ordinary range. Deleting and handling outlier. The following section detail the method of use used in the deleting outlier in a univariate and multivariate situation. Once identified that may profited to aid in replacing them into one of the four classes just described. Finally, the researcher must decide the retention of the exclusion of each outlier, judging not only from the characteristic of the outlier but also from the objective of the analysis. Method of defecting outlier. Outlier can be identified from the univariate, bivariate or multivariate perspective based on the number of variables. Consider the researcher should be utilized as many of these perspectives as possible, looking for the consistent pattern across the pattern to identify the outlier. The following discussion detail the process of involve the each of the three perspectives. Method of deleting outlier. Number first, univariate deletion. Second, the bivariate deletion. The first we will read about the univariate detection. The univariate identification of the outlier examining the distribution of the observation for each of the variable in the analysis and the select of the outlier those case falling of the outlier range high or low of the distribution. The primary issue is establishing the threshold for designing of the outlier. The typically approach first convert the data values to standard source which have means 0 and the standard deviation of the 1. Because the values are expressed in a standardized form, comparison across the variable can be made easily. In either cases, the researcher must recognize that certain number of the observation may occur normally in this outer range of the distribution. The researcher should strive to identify only those truly distinctive observation and designate them as outlier. Let's talk about the biovariate detection. In addition to the univariate assessment, pairwise variables can be assessed jointly through scatter plot. Case that fall markedly outside the range of other observation will be seen as isolated point in the scatter plot. To assist in the determining the range of the observation is two-dimensional portrayal, and the ellipse representation of a bivariate normal distribution. Confidence interval typically set as the 90% or 95% level. It's superimposed over the scatter plot. This ellipse provide a graphical portrait of the confidence limit and the facilitating identification of the outlier. A variant of the scatter plot is termed the influence plot, with each point varying the size of relation to its influence of the relationship. Each of these methods provide an assessment of the uniqueness of the each observation in relationship to the other observation based on the specified pair of the variables. A drawback of the bivariate method in the journal is the potentially large a number of scatter plot that arise the number of variable increase. For three variable, it is only the three graphs for all pairwise comparison, but for five variable it takes 10 graphs, and the 10 variables take 45 scatter plot. As a result, the researcher should limit the journal use of bivariate method to the specified relationship between the variables, such as the relationship of the depend on the versus independent variables in regression. The researcher can examine the set of the scatter plot and identify the general pattern of one more observation that would result in their diagnosis of outlier. Let's talk about the multivariates detection. Because most multivariates analysis involve more than two variables, the bivariate method quickly become the inadequate for the several reasons. First, they require a large number of graphs. As discussed previously, when the number of variable research even method create size. Second, they are limited to two-dimension variable at a time. Yet, when more than two variables are considered, the researcher made a means to objectively measure the multidimensional position of the each observation relative to some common points. This issue is addressed set by the Mahalanobis t-square measures a multivariate assessment of each observation across the variables. The method measures each observation distance in a multidimensional spaces. Random means center of the observation provide a single value for each observation no matter how many variables are considered. Higher D2 values represent observation further remove also has the drawback of only providing an overall assessment, such as it provide no insight as to which particular variable might lead to a high d-square value. For interpretation purpose, the Mahalanobis d-square measures has statistical property that allow for significant testing. The D2 measures divided by the number of variables involved. D2 DF is approximately distribution as a t-value. Given the nature of the statistical test, it is suggested that conservative level of significance, for example 0.005 or 0.001, be used to method value for designation. As an outlier, those observations having the T2 value exceeding 2.5 in a small sample and 3 to 4 in the large sample can be designed as possible outlier. Once identified as a potential outlier on the D2 measures, observation can be examination in terms of the univariates and the bivariates method discussed earlier to more fully understand the nature of uniqueness. Outlier designation. Let's talk about the designation. With the univariates and multivariate diagnostic methods, the researcher has a complementary set of perspectives with which to examine observation as their status as outlier. Each of these methods can provide unique perspective on the observation and use to concerned manner to identify outlier, See result in thumb 4. When the observation have been identified by the univariates and the multivariates method as possible outlier, the researcher must then select only observation that demonstrate real uniqueness in comparison with the remainder of the population across the many pairs types of the possible. Research must refrain from the decisioning too many observation and outlier. Don't scum to the attempt of the eliminating those cases no consistence with the remaining cases just because they are different. Let's talk about the outlier description and the profiling. Once the potential outlier are identified, the research should be generated profile of each outlier observation and identify the variables responsible for its being an outlier. In addition to this visual examination, the researcher can also employ multivariates techniques such as discriminant analysis or multiple regression to identify the differences between the outlier and the observation. If possible, the researcher should assign the outlier to one or four classes described earlier to assist in the retention of the deletion decision to made next. The researcher should continue this analysis until satisfied with the understanding and aspect of the case of diagnostic outlier and observation. Next video will talk about thumb rule 4, retention on deletion of the outlier. After the outlier are identified, profiled and categorized, the researcher must decide on the determining the deletion of the each one. May philosophies among researchers often guidance is proof as to how to deal with the outlier. Our belief is that they should be retained unless demonstrable proof indicate that they are truly aberrant and not representative of any observation in the population. If they do portray representative elements of the single of the drop location, they should be retained the ensure generalizability to the entire population. As outlier are deleted, the research must risk of comparison, but the multivariate analysis but limit of the generalizability if they are problematic in the particular technique. Next thumb rule will discuss for the upcoming video.